Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0641, indicates a malfunction related to sensor reference voltage A in the Honda Civic built between 2016 and 2021. This issue pertains to the voltage supplied to several engine management sensors that are essential for proper vehicle operation. These sensors include the crankshaft position, CKP, sensor, manifold absolute pressure, MAP sensor, fuel rail pressure sensor, throttle body, accelerator pedal position APP sensor, and output shaft speed sensor. A fault in the reference voltage can lead to inconsistent data being sent to the powertrain control module PCM, potentially resulting in poor engine performance, increased emissions, or even stalling. Understanding this code is key to diagnosing any related issues efficiently. The troubleshooting process will guide technicians to locate and address the root cause of the DTC. DTC P0641 specifically points to a malfunction in the sensor reference voltage A. The critical components affected by this voltage include the CKP, MAP, and fuel rail pressure sensors, which provide essential input to the PCM for engine management. The CKP sensor detects crankshaft rotation to manage ignition timing, while the MAP sensor measures manifold air pressure for fuel injection purposes. The fuel rail pressure sensor monitors the pressure within the fuel rail, crucial for maintaining optimal fuel delivery. Other components, such as the throttle body and APP sensor, also depend on this voltage for their operation. The output shaft speed sensor aids transmission management, showing how intricately these sensors are linked. These components are distributed throughout the engine bay, typically in locations such as near the intake manifold and fuel rail, making the proper identification of their connections crucial for effective troubleshooting. The potential causes of DTC P0641 include bad connections at the associated sensors, which may result in poor voltage transmission. Wiring issues, particularly in the voltage-controlled circuit, VCC lines, are common culprits as these wires connect the sensors to the PCM. A faulty PCM itself may trigger this DTC if it malfunctions and fails to provide the necessary voltage, although this is less frequent than sensor and wiring issues. An intermittent sensor failure might also manifest as P0641, where the problem occurs sporadically, making it difficult to diagnose because the vehicle might sometimes operate normally. It's critical during this troubleshooting phase to methodically assess each of these potential causes to determine the root of the malfunction. When DTC P0641 is triggered, one of the primary symptoms is the illumination of the check engine light, CEL, on the dashboard. This is an important notification that the vehicle's onboard diagnostics have detected an anomaly. Engine performance may also degrade, leading to issues such as stalling or misfiring, as the engine management system struggles to maintain optimal operation. Additionally, P0641 could inflate emissions levels, which can impact environmental protocols and vehicle assessments. Drivers might notice sporadic issues, which can be confusing, particularly if the vehicle appears to function normally at times. Recognizing these symptoms is essential for technicians as they move through the troubleshooting process. The first step in troubleshooting DTC P0641 involves putting the vehicle in the on mode, which allows the electrical systems to initialize and prepares the vehicle for diagnostics. Using the Honda Diagnostic System, HDS, clear any stored diagnostic trouble codes and then check again for any pending or confirmed DTCs. This process is crucial as it verifies whether the problem persists or if it was a sporadic issue. If DTC P0641 returns, the next step is to further investigate potential causes. However, if it does not return, it might indicate an intermittent failure, leading the technician to check for poor connections or loose terminals at the PCM and the affected components. In the second step of troubleshooting, the vehicle should be turned off and brought to the lock position. Disconnect the connectors of the CKP sensor, map sensor, fuel rail pressure sensor, throttle body, APP sensor, and output shaft speed sensor. Each of these components must be systematically disconnected to isolate the issue. After disconnecting, turn the ignition to the on position once more, which supplies power to the system without starting the engine. Clear the DTCs using the HDS again and check for the presence of pending or confirmed DTCs. This isolation helps narrow down the area of potential failure by determining if the voltage reference signal issue exists while these sensors are disconnected. In Step 3, the focus shifts to checking each of the sensors that were previously disconnected. Reconnect the sensors one at a time and continue to monitor the system using HDS for any emergence of DTC P0641. This meticulous approach allows a technician to pinpoint which specific sensor may be causing the malfunction. If the code reappears upon reconnecting a particular sensor, that sensor is likely faulty and needs replacement. However, if DTC P0641 does not reappear, the next logical step is to examine the connections and terminals at the PCM and the other sensors for any signs of looseness or corrosion. This systematic, one-at-a-time method is vital for ensuring an accurate diagnosis. Moving to the fourth step, start by turning the vehicle to the off position. Use the HDS to jump the SCS, service check signal line, and wait for more than 1 minute. This procedure essentially allows the system to prepare for further checks. Disconnect the necessary connectors for the PCM, including connector A and E, to access the voltage supply lines. Now, the next critical task is to check for continuity between the specified test points and the body ground. This condition verifies whether there are any shorts to ground in the VCC wires, which are responsible for carrying voltage to the sensors. If continuity exists, this indicates a short, and necessary repairs should be performed. If no continuity is found, technicians will proceed to the next troubleshooting phase. The fifth troubleshooting step requires the vehicle to be in the on position once again. Here, technicians must measure the voltage between the previously identified test points and the body ground. This testing is critical to ascertain if there is voltage present on the VCC lines when the sensors are dissected from the PCM. If voltage is observed, this indicates a short to power, necessitating repairs to the wiring that connects the PCM to the disconnected components. Conversely, if no voltage is found, this suggests that the VCC wires are okay. Technicians should then consult authoritative service information for any further DTCs associated with the current symptoms. And they may substitute a known good PCM to see if the issue resolves, ultimately pointing to the original PCM for replacement if the DTC disappears. Once repairs have been made according to the previous steps, it is essential to conduct a final repair verification process. This starts with rechecking for the presence of DTC P0641 using the HDS. Successful clearance of this code will indicate that the issue has been effectively resolved. In addition to checking for DTCs, it's critical to monitor overall vehicle performance to ensure that the engine operates smoothly without hesitation or stalling. Any remaining issues should also be evaluated to confirm that addressed repairs have rectified the problem. This step serves as a fundamental quality control measure in ensuring the reliability and safety of the vehicle following any maintenance actions. To prevent future occurrences of DTC P0641 and similar electrical issues, regular maintenance is vital. Scheduling routine inspections of wiring and connectors will help identify potential problems before they escalate. Ensuring that connections remain secure can significantly reduce the risk of intermittent faults that might trigger DTCs. Additionally, using high-quality replacement parts when repairs are necessary is crucial for retaining the integrity of the vehicle's electrical systems. Educating vehicle owners about the importance of timely diagnostics and maintenance can also contribute to the long-term health of their engine management sensors and systems. In summary, DTC P0641 regarding sensor reference voltage A malfunction highlights a significant aspect of Honda Civic engine management. Understanding how this DTC affects critical engine sensors can help in promptly diagnosing the causes behind it. Following a structured troubleshooting approach allows technicians to effectively pinpoint and resolve issues efficiently. Lastly, implementing preventive maintenance practices can drastically reduce the chances of encountering this DTC again in the future. Staying informed about the vehicle systems, along with routine checkups, is key to ensuring optimal performance and longevity of the Honda Civic. Please like and subscribe to the channel. See you next time.